In our last lesson, we learned the Pythagorean theorem. The Pythagorean theorem said that a squared plus b squared equals c squared. The thing about the Pythagorean theorem, in the previous lesson, we learned the Pythagorean theorem. The Pythagorean theorem said that if you know two sides of a right triangle, you can solve for the third side using c squared equals a squared plus b squared. For instance, if I know side B and side C, I can calculate the length of side A. In today's lesson, we're going to figure out the sides of triangles, not based on the other two sides, but based on the length of one side and one of the angles in the triangle. To do that, we're going to review the three trigonometric relationships known as sine, cosine, and tangent. And these are three functions that require an angle. The angle often is used with the Greek letter theta. When a Greek person sees this symbol, they'll go th. We use it in engineering and science often to represent an angle. We're going to go away from using A, B, and C to describe our triangle now. We're going to use new names. The hypotenuse is still the hypotenuse. It's the longest side of our right triangle. There are two legs that support the hypotenuse in a right triangle. Now, if I am talking about this angle, the side that's across the angle is called the opposite side. But the side touching the angle is called the adjacent side. And the ratios of these sides are called sine, cosine, and tangent. For instance, opposite divided by hypotenuse, the ratio of those two sides, is equal to the sine of the angle. And the adjacent divided by the hypotenuse is equal to the cosine of the angle. And the opposite over the adjacent, the two legs, their ratio is tangent theta. Let's delve into it with some examples. But before we do that, I must remind you that all of these tricks only work with right triangles. One of the angles has to be a 90-degree angle, and the longest length is the hypotenuse across from the 90-degree angle. And remember that adjacent and opposite, those legs and those names for those legs are relative to the angle that we pick. So for this angle, this is the opposite side. But if I were to choose the upper angle, the adjacent becomes the opposite. Let's take a look here at this triangle example. In this example, I'm given an angle of 40 degrees, and I'm given the hypotenuse. And the question is asking about this side. Well, what is this side in relation to that angle? Well, this is the opposite of that angle. So I have a hypotenuse and I have an opposite. Going up here to SOHCAHTOA, which is how we memorize the relationships here. Given an opposite and a hypotenuse, I'm going to use the sine function. So I'm going to write this as the sine of 40 degrees equals the opposite over the hypotenuse. In other words, the sine of 40 degrees is, well, I know the hypotenuse is 15, and the opposite here, that's what I'm looking for. I'm going to solve for the opposite by multiplying 15 on both sides, and that cancels out. And now I have 15 sine of 40 degrees equals opposite. Now this is where students start to get confused. A lot of students will multiply these two numbers, but that's not what this says. This says 15 times the sine of 40. Sine is a function. 40 is the input value of the function. What's the output value? Well, that's why we have a table of trigonometric ratios, which is on the back of your cover sheet. And we have to go down here to 40 degrees. And we find out that the sine of 40 degrees is 0.6428. So I'm going to do 15 times 0.6428. And when I multiply these numbers together, it will give me the opposite side. I then multiply those numbers, and I find out that the side is approximately 9.642. So in summary, given the angle of 40 degrees, and knowing that the hypotenuse was 15, using the sine function, I was able to find the opposite side. And it is about 9.642. It's actually more decimals than that. We are approximating here. This table of trigonometric ratios is also an approximation. And it makes sense because my leg is going to be smaller than my hypotenuse. Let's move on to the next example. In this example, I'm given this side, which is a leg, and an angle of 15 degrees. Now, the side they gave me, that's the adjacent side, because this is the side touching my angle. And it's asking me for the opposite side. So I want to know the opposite. I'm given the adjacent, and I'm given the angle. Going up here to SOHCAHTOA, I need to know two things to find the third. Since I'm looking for the opposite given the adjacent, tangent is a great candidate here. So the formula for tangent of theta is opposite over adjacent. My angle is theta, so tangent of 15 degrees is equal to my opposite, which I don't know, so I'm just going to write op, and my adjacent, which is 80. Solving both sides by multiplying 80, that will solve for op, the opposite side. And I'm going to do 80 times the tangent of 15. So now I have to go to my table here. I'm in the tangent column. I'm going to go down here to 15 degrees, and I go to the tangent. It's 0.2679. 0.2679. And I'm going to multiply those numbers to get my answer. And as you can see here, my answer is 21.432. That's the length of that side. Now some of you might try to type 80 tangent 15. And as you can see here, it doesn't give us the answer we're looking for. And the reason why it didn't give us the answer we're looking for is when you click on the gear and you go down to more options, you can see that our calculator is in a thing called radians, which we haven't learned yet. If we want to use 15 and interpret that as 15 degrees, I have to turn my calculator into a degree calculator. So having this on the wrong thing can cause a major disaster for you on the test. Make sure that if you're using degrees, that your Desmos is set to degrees. In my next example, we're looking for this side. We have a 30-degree angle. It looks like they gave us the hypotenuse. And what side is this in relation to the angle that I know? Well, this is obviously the opposite side of the angle. So I have opposite and hypotenuse. The best thing to use would be this relationship, which is sine. Sine of theta equals opposite over hypotenuse. And sine of 30 degrees. I'm going to use degrees every time I use degrees. I don't know the opposite side, so I'm going to leave it blank. And my hypotenuse is 100. I'm solving for an opposite. I'm going to multiply 100 on both sides. And now I have 100 sine of 30 degrees equals opposite. All right, now we're going to reference our table of trigonometric ratios. I'm looking for the sine of 30 degrees, so I'm going to be looking at this column. I go down here. Interestingly enough, 30 degrees is highlighted on this table, and there's a reason for that. And one of the reasons why is because look here. It's a perfect 0.5. That's very accurate. That's another way of saying half, right? So this is 100 times 0.5. I don't even need a calculator for this one. 0.5 times 100, that gives me exactly 50. So 30 is a very interesting angle. The opposite of a 30-degree angle will always just be half of the hypotenuse. And that's actually kind of a fact you need to memorize. You need to memorize this and starting now. The sine of 30 degrees is equal to 1/2, or in other words, it's equal to 0.5.